The story of Doom 3 source code and how beautiful it is. Yes, beautiful. Allow me to explain. I've never once. Okay, I have. Okay, I'm guilty. I'm guilty of it. I've seen code that I went, this is beautiful code. It's infrequent, but it certainly happens. Okay, it does happen. After releasing my video game Dyad, I took a little break and I read some books and watched some movies, and I'd put off for too long. I was working on the European version of Dyad, but at that time, what is the European version of Dyad? Is that where they drink like tea? They complain about, they like sue people for privacy stuff? What is it? I don't know. What is the European version? They just work less hard? Got them. First try, American View, coming in hot. But that time was mostly waiting for feedback from Sony Quality Assurance. So I had a lot of free time. After loafing around for a month or so, I started to seriously consider what I was going to do next. I wanted to extract the reusable game engine-y parts of Dyad for a new project. You can actually teabag people. Ooh, is that European? Is the teabagging a European approach to saying good game? Let's see. When I originally started working on Dyad, there was a very clean, pretty functional game engine I created from an accumulation of years of working on other projects. By the end of Dyad, I had a hideous mess. Sounds like every beautiful piece of code I've ever started with, honestly. In the final 6 weeks of Dyad development, I added over 13,000 lines of code. Main menu CC ballooned to 24,500 lines of code. Love it. I love it. Menus are so effing hard. Menus are just the worst. They're just forms. It's forms all over again. It's just forms all over again. The once beautiful source code was a mess riddled with if-defs, gratuitous function pointers, ugly inline SimDNA's ASM code. I learned a new term, code entropy. Yes, it's real. I searched the internet for other projects that I could use to learn how to organize hundreds of thousands of lines of code. And after looking through several large game engines, I was pretty discouraged. The Dyad source code wasn't actually that bad compared to everything else out there. Yeah, inline SimD in your menu is wild. Like, what the hell's happening in your menu that you need SimD going on? Like, I thought menu systems were pretty simple. Like, you're painting some squares with some textures on it, waiting for input to change what's being focused. Okay, maybe I'm being ignorant here, but in my head, that is like what's happening. You know what I mean? Unsatisfied, I continued looking and found a very nice analysis of id Software's Doom 3 source code. I spent a few days going through Doom 3 source code and reading Fabian's excellent article I retweeted. All right, check out the article. And look, hey, it's Shawn McGrath. I'm actually going to go to Shawn McGrath over here, and we're going to hit a little follow on this because, you know, I just boom, followed. Okay, do the same thing. It was the truth. I've never really cared about source code before. I don't really consider myself a programmer. Programs a video game, arguably the hardest medium to actually create in, makes a successful video game. I'm not really a programmer. I'm good at it, but for me, it's just a means to an end. Going through Doom 3 source code really made me appreciate good programmers. To put things into perspective, Dyad was 193,000 lines of code, all C++. Again, not a programmer, people. Not a programmer. Doom 3 has 601,000, Quake 3 has 229, and Quake 2 has 136. That puts Dyad somewhere between Quake 2 and Quake 3. These are large projects. When I was asked to write this article, I used to use it as an excuse to read more source code from other games and to read about programming standards. After days of research, I was confused by my own tweet that started this whole thing. What would nice looking or beautiful, or for that matter, actually mean when referring to source code? I asked some programmer friends what they thought that meant. Their answers were obvious, but still worth stating. I actually honestly don't know what good-looking source code is. Honestly, I have no idea. I think good-looking source code changes, and it's also like a measure of your understanding as well of the code, right? Like if you understand the problem, and then you understand how someone framed it, and you're like, oh, that's good. But you could look at a piece of code, and you could see like, man, I don't understand the problem, and I don't really understand what's going on here. This is bad code. Like that might just be purely a perspective, you know what I mean? Code should be locally coherent and single-functioned. One function should do exactly one thing. I actually don't necessarily agree with this. It should be clear about what it's doing. Local code should explain, or at least hint at overall system design. Interesting. Code should be self-documenting. Comments should be avoided whenever possible. Love it. Absolutely love this last part. Honestly, comments for the most part are really dumb unless if it's like a very special circumstance. Duplicate work when both writing and reading code. If you need to comment something to make it understandable, it should probably be written different or rewritten. I don't agree with that last take. Some things are just complicated, right? Some things take you debugging for 10 hours to know this one special case, and so that one special case should be like, hey, to save you 10 hours, You should know in this particular situation, this thing happens, and that's that, right? There's an id Tech 4 coding standard doc that I think is worth reading. I follow most of the standards, and I try to explain why they are good and why specifically they make Doom 3 code so beautiful. All right. Unified parsing and lexical analysis. One of the smartest things I've seen from Doom is the generic use of lexical analyzer and parser. All resource files are ASCII files with a unified syntax, including scripts, animation files, config files, etc. Everything is the same. This allows all files to be read and processed by a single chunk of code. The parser is particularly robust, supporting major subsets of C++. By sticking to a unified parser and lexer, all other components of the engine needn't worry about serializing data, as there's already code for that. This makes all other aspects of the code cleaner. Okay, I mean, I think that's just universally good advice. If you're going to have some sort of scripting thing, make the scripting thing good, right? This is Lua in a nutshell, right? If you're going to use Lua in your project, it's probably better than you making up your own DSL, right? Like when you use Vimel is a little crazy. It's kind of wild. It just is. Whereas you use Lua and you're like, not bad. It's not bad. Right? Const and rigid parameters. Doom's code is fairly rigid, although not rigid enough in my opinion with respect to const. Const serves several purposes which I believe too many programmers ignore. My rule is everything should be always const unless it can't be. I wish all variables in C++ were const by default. Oh my goodness, rustation in the making. Dude, he's getting rustified. Bevy engine coming next. You can feel it. You can feel it happening. The hair is slowly turning blue from the roots. You can see it. Doom almost always sticks to a no in-out parameter policy, meaning all parameters to a function are either input or output, never both. This makes it so much easier to understand what's happening with a variable when you pass it to a function. For example, by the way, this statement right here is like JavaScript people don't understand. Right? This is like, you know, the American mind can't comprehend. This is the JavaScript mind cannot comprehend this statement, which is that there's input and output variables passed to a function, right? Like that's a real thing you do, and you see it a lot in C. It's great. It's beautiful, right? It's beautiful. It is amazing. And when you learn how to use it, it's really useful, right? It's like a whole nother way to solve things. This function definition makes me happy. Just a few const, and I know many things. The id plane that gets past an argument will not be modified by this function. I can safely use the plane after this function executes without checking for modifications of id plane. Yep. I assume this is called id, right? Right? This is id, the software studio, so id plane. That's what I just assume. I know the epsilon won't be changed within the function, although it could easily be copied to another value and scaled, for instance, but that would be counterproductive. Front, back, front on plane edges, and back on place edges. Now we're getting into game programming. Are out variables. These will be written too. The final const after the parameter list is my favorite. It indicates id surface split won't modify the surface itself. This is one of my favorite C++ features missing from other languages. It allows me to do something like void f const surface s. Okay, yes. Again, Rust. Just saying, he's ready. Okay, this guy's ready. Desires it. Wants it. Can't wait to have it. Rust. If split wasn't defined as split const, this code would not compile. Now I know that whatever is called f won't modify the surface, even if f passes the surface to another function or calls some surface method. Const tells me a lot about the function and also hints at a larger system design. Simply by reading this function declaration, I know surfaces can be split by a plane dynamically instead of modifying the surface. It returns new surfaces, front and back, optionally front on plane edges and back on plane edges. Oh, he called it back on place edges up here. See? I was a little bit confused, but okay, we see it now. We see it now. Okay. Yeah, I mean, this is good. I mean, this is obvious programming goodness is when you know a lot about a function. The more you can know from the signature, the better it is, right? That's why TypeScript is popular, because you have the ability to read only if you need to. You have the ability to define types. I mean, that's why dynamic typed languages are generally not considered that great, is because, I mean, generally, there are people that love typed, untyped, or secretly typed languages. I call them secretly typed because they're still very much typed. They're just hidden behind some opaque surface, right? DHH. So I get that. The const rule has and no input-output parameter is probably the single most important thing, in my eyes, that separate good code from beautiful code. Okay, I can buy this. It makes the whole system easier to understand and easier to edit and refactor. Yeah, agreed. Minimal comments. This is a stylistic issue, but one beautiful thing that Doom usually does is not over-comment. I've seen way too much code that looks like this. That looks like, I find this extremely irritating. I can tell what this method does by its name. If its function can't be inferred from its name should be changed. If it does too much to describe in its name, make it do less. If it really can't be refactored and renamed to describe its single purpose, then it's okay to comment. I think programmers are taught in school that comments are good. Yes, we are. I was required to comment every line in every lab until I got out of school. And during my time working on my own startup is where I learned I ain't gonna comment shit, okay? Future me's problem is remembering what I did, and that's that. I'm gonna have to remember what I did, and if I don't remember, I hope I wrote it well enough, which allowed me to come up with a good way to do what I would call like the 75% rule. Program code, 75% good enough, first try, and you can go very, very far very fast. Now, it's not the 100% solution. It's not one that's going to be infinitely scalable, but it's pretty good. It can get you far enough into the project to the point where refactoring makes sense. You know what I mean? Comment every line is so dumb. It absolutely is. But it's school, and they require that. Comments aren't bad unless they're totally necessary, and they're rarely necessary. Doom does a reasonable job at keeping comments to a minimum. Using id surface split example, let's look at how it's commented. Split the surface into front and back surface. The surface itself stays unchanged. Front and back are optionally stored indices in the to the edges that lay on the split plane. Return side ? The first line is completely unnecessary. Agreed. Yes, because it's part of the const definition. It's already in the definition. We learned all that information from the function definition. The second and third lines are valuable. We could infer the second line's properties, but the comment removes potential ambiguity. Okay, that's good. I actually really like this. I really like this observation. Don't restate what types can state for you. And I think this is a good lesson for all the TS Andes out there. All you TS Andes, in the functions you don't mutate variables, maybe it's more and more valuable to start passing in read-only. You know what I mean? Maybe we should start making it normal to do read-only regularly. I don't, but maybe that's a good idea, is just start read-only to like signify to other people the usage of this function. Could be good. Or object freeze.life. No, see, I don't like that. I don't like object freeze because that's actual programmatic differences. Whereas you're stating what a function will do. This function will not edit this object coming in. Like, to me, that's a really great, it's an API design choice. Object.freeze is pre-API. You pass that in, and if you attempt to mutate the object, I don't know if object.freeze throws. Does object.freeze throw? I don't even know. Honestly, I have no idea. Const a equals foo5 object.freeze a. I forget if it returns something. Does it return something? B. Okay, b dot bar equals 5. See, b, right? It doesn't even tell you, so it silently errors, right? And so by silently erring, that's like the worst of all problems. I wouldn't want this, right? I don't want that. I want code that I know what happens. So by specifying on the API side whether or not it's going to change, that's good, right? Strict mode throws, okay, strict mode throws. Okay, strict mode throws, that's good. But again, that means every time you look up or mutate an object, like, I don't really want to have to go through all this. You know what I mean? Yuck. Design's better than that, right? Design it well. You don't need to enforce it if it's designed well. Anyways, the first line is completely unnecessary. We learned all that information from the function definition. The second and third lines are valuable. We can infer the second line's properties, but the comment removes potential ambiguity. I actually completely read that already. Doom's code is, for the most part, judicial. It should be judicious. Judicial is a very different word here. It's not judicial. It's judicious with its comments, which it makes it much easier to read. I know this may be a style issue for some people, but I definitely think there's a clear right way to do it. For example, what would happen if someone changed the function and removed the const at the end? Then surface could be changed from within the function, and now the comment is out of sync with the code. Great example. Great example. Extraneous comments hurt the readability and accuracy of code, thus making the code uglier. Spacing. Doom does not waste a vertical space. I like this for the most part. Here's an example from T stencil arc chop winding. I don't know this one. I can read the entire algorithm on a fourth of my screen, leaving the other 3/4 to understand where the block of code fits relative to its surrounding code. I've seen too much code like this. This is going to be another point that falls under style. I programmed for more than 10 years with the ladder style, forcing myself to convert to a tighter way while working on a project about 6 years ago. I'm glad I switched. The ladder takes 18 lines compared to the 11 lines in the first. That's nearly double the number of lines of code for the exact same functionality. It means that the next chunk of code doesn't fit on the screen for me. What's the next chunk? Okay, I see this argument. This argument I really fall into, like, I'm not sure. I really don't know on this one, because here's the deal. Is like, I do like some vertical spacing. I like to separate out ideas. What I mean by that is, like, I like a variable initialization section. It just feels good for me to have, like, hey, I'm going to make 3 variables, and I'm going to have, this is the thing. And then I'm going to have, like, an action. You know what I mean? So here, let's go over to Harpoon. Like, I like this, right? I'm stating some things with this, right? I'm stating, here's me reassigning for defaults. Here's me creating new ones. Here's me leaving or doing whatever, right? I like doing things in chunks, right? I don't know why. For me, I like that. I could tighten this all up. I'm just not sure if it's really that great, right? Like, is that any better? Is that more readable? Probably just more of like a get used to it. You know what I mean? Yeah, we're missing the code blocks for sure. Some people like this. I program with a lot of people that prefer this. I kind of like the spacing. You know what I mean? I've always been kind of a space Andy. Now, I could go this way versus the other way. I don't know which way. I'm kind of like initializing and using it in one spot. I never know the way to do things, right? For me, vertical spacing I find more comfortable. I don't know. That code makes no sense without the previous loop chunk. If I didn't respect vertical space, their code would be much harder to read, harder to write, harder to maintain, and less beautiful. Okay, so we're going to say we disagree with this one generally. Here, I'm going to take a little poll while I keep reading, and we'll come back to that, because I'm actually curious how people really feel about this. Another thing that it does that I believe is right and not a style issue is always use these things even when optional. Okay, I agree with this. This is right. This is right. This is 100% right. I think it's a crime to skip the brace brackets. I've seen so much code like this. I wonder why we don't get to see the code. We're missing the code, so just deal with it. The ugly code, like, you know what he's putting in here. It's an if statement, or it's a for loop. You know how have you ever seen a for loop and then an if statement? A for loop in the if statement? Oh, you think it's dark readers? Oh, how much do you want to bet you're right on that one? I don't think it's dark readers here. I'm going to refresh. There we go. Hard refresh, and always, right? I don't think it's, yeah, we're just not seeing it. We're just not, I don't think it's dark readers. I think something else is going on here, and I don't understand what it is. But you get the idea. It's like a for loop or an if statement with no squirrelies on them. You know, that's ugly code. It's the worst than putting braces on their own lines. I couldn't find a single example in ID's code where they skipped the braces. Omitting the optional braces makes parsing this while block. Okay, they're using a while block. See, that's crazy. More time consuming than it needs to be. Have you ever added a comment and you didn't realize someone didn't put in the squirrely braces? Like, I don't even read the squirrely braces. Like, they're like gone in my brain. And I will put in a log line and then ruin the if statement because of it. I absolutely hate that. My goodness. All right. Absolutely. Love that. Okay, I love that one. Minimal templates. It did a huge no-no in the C++ world. They rewrote all required STL functions. I personally have a love-hate relationship with STL. In Dyad, I used it in debug builds to manage dynamic resources. In release, I baked all the resources so they could be loaded as quickly as possible and don't use any STL functionality. The STL is nice because it provides fast generic data structures. It's bad because it can often be ugly and error-prone. For example, let's look at vector T class. Let's say I wanted to iterate over each element. Dang it, this is where I really wish the code would actually load. That doesn't simplify with C++ 11, so this must be doing that whole like iterator thing. Grab the iterator, plus on the iterator, const auto a colon. You know the thing. I don't know. Personally, I don't like to use the use of auto. Called the auto. I think, let's see, it makes the code easier to write but harder to read. I might come around to the usage of auto in the coming years, but for now, I think it's bad. I actually agree with this. Auto is just not the same. It doesn't feel the same. It just never feels the same. Oh, you're right. Maybe it is ad blocking. Here. How do I turn this thing off? I've never actually turned it off for a particular site. There we go. I refresh the page, and now it's taking literally forever. Well, I mean, this might be part of the problem. Okay, see, so this is part of the thing that, like, maybe we don't want that. I still didn't get those code blocks, though. I'm still not getting the code blocks, and now I'm just getting way more ads, okay? I'm getting all the ads, none of the code blocks, okay? Gee, that's going to be typed correctly by every programmer, every type. Again, we don't even know what they're saying, but I think I believe what he's trying to say. Yeah, I got to get that. I got to get that. I got to get that block back up, baby. Baby, let's get that block back up. All right. All right, that's going to be typed correctly by every programmer every time. It removes all ambiguity. They rolled their own generic containers, string classes, etc. They wrote them much less generic than the STL classes, presumably to make them easier to understand. They're minimally templated and use id-specific memory allocators. STL code is so littered with template nonsense that it's impossible to read. Fair take. Have you ever tried to walk through some of the stuff? It's very difficult to understand. C++ code can quickly get unruly and ugly without diligence on the part of the programmers. To see how bad things can get, check out the STL source code. Microsoft's and GCC's, man, just calling out GCC. Dude, STL is crazy, okay? STL is difficult. Prime, why does everyone call me Prime? Oh, the Wayback Machine has the code. Thank you, everybody. Thank you. I wonder why the code got deleted. Because I actually really wanted to see this. Yeah, see, again. Oh, interesting choice of spacing. Look at the spacing. It's actually on the almond style versus whatever style. I forgot what it is. But I actually, I actually prefer this code versus this code. Yeah, that's fine. I prefer my braces. I prefer my squirrely braces on the right side. You're welcome, by the way. Yeah, WordPress must have got pronounced, right? Yeah, I mean, this is obviously crazy. If you program like that, you should be shot. In the ankle, of course. Okay, like a wing clip. So it hurts. You have to go get some stitches, but like you're not dead or anything, okay? I'm not saying you should be murdered, okay? In-game also. So you can just use like a Tarkov healing pack and you're back in the game, okay? Now you're going to drink a little bit of condensed milk. You're dead, okay? Everybody knows that. You're dead. You got some condensed milk? You're dead. I love that, by the way. The fact that you drink condensed milk and you die. It's just so good. Anyways, all right, minimal templates, blah, 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 blah. All right, yeah, look, this auto it a vector begin, it does not equal vector type end, I++. Like, I've always hated that. I think this is a disaster. Luckily, they made it nicer. And this also, like, I literally have right there, Effective C++ 3rd edition. I have a tour of C++ as well. I have, I understand where they were going, and there's a lot of beauty with the ideas of making things iterators and how you get them and how you delete from them and all that. It's absolutely wonderful, but at the exact same time, it is a huge pain in the ass, okay? C++, it really is. You know what I mean? Like, the Wayback Machine totally sucks. What is this? Why do I gotta have the code? Why do I have to keep... Okay. And dang it, I think I'm using Firefox still, which makes it virtually impossible for me to edit because I don't know how to use their thing, okay? I don't even know how to use their thing, okay? What is this? What is this section? Can I just delete you? Create, is there a delete? Is there not a delete? Tell me there's not. Okay, there is a delete. Okay, that didn't work. Didn't work. Didn't work. Okay. What are you floating or something? Let me guess, you're floating. You're floating, aren't you? So we're going to go like this. Style equals float left. Space. Enter. Damn, it's not floating. I thought it was floating. I thought we had a float right there. I thought we had a float. I thought we had something there, okay? I thought we had something there, but we don't. I'm not really sure. Skill issues? It's skill issues. Importante. Bang. Importante. Nope, importante did not work. Here, I'll go like this. We'll just keep it easy. Margin left is negative 100 pixels. Damn it, that didn't work either? Dude, I thought I had it. Is it styles, not style? Is that my problem? Is it styles? No. I don't know what it is. Okay, whatever. We're going back to, I'm going to go right to here, and I'm going to bring over chat, okay? Because this is the only way I can do this, okay? I can't read stuff that's way to this side, okay? It's weird. CSS, am I right? Am I right? Am I right? I'm not trying anymore. Okay, C++ code can get unruly and ugly without diligence on the part of the programmers. To see how bad things can get, check out the STL source code, Microsoft's GCC's, blah, blah, blah. We already read all this. All right, take a look at Andres Alexandrescu's Loki library, or the Boost libraries. These are written by some of the best C++ programmers in the world, and great care was taken to make them as beautiful as possible. They're still ugly and basically unreadable. It solves this problem by simply not making things overly generic. They have a hash table v and a hash index class. Hash table forces the type to be const char star. The hash index is an int to int pair. This is considered poor C++ practice. They should have had a single hash table class and written partial specialization for key type const char star and fully specialized int. What it does is completely correct and makes their code much more beautiful. It's also specific. Implementation specific stuff can be really beautiful. You know, it can be really easy to understand. I do agree with that. It would be considered by many to be good practice to create specific computation class as a parameter to the hash table like so. Okay, beautiful. Compute hash. This could be specialized for a particular type. Okay, beautiful, wonderful. Then you could pass the compute hash for type as the hash computer for the hash table. Classic, the hash computer for the hash table is going to be the compute hash for type. This is similar how I did it. It seems smart, but boy, is it ugly. What if there are more optional template parameters, maybe memory allocator, maybe a debug tracer? You'd have a definition like this? Absolutely. This is real. This is real. I've seen this stuff. I've seen it. It's not awesome. I am not happy when I see that stuff. Did I just see a study time follow or a study time raid? Hey, thank you, study time, for that beautiful raid. Thank you. Appreciate that. What a wonderful day. So good. What does this even mean? I don't even know. There's too many parameters at this point. I can't even find the method name without some aggressive syntax highlighting. It's inconceivable that there'd be more definition code than body code. This is clearly not easy to read, thus not beautiful. I actually fully agree with this statement. If your function definition requires more code than the code of the body, something has gone off the rails. You are clean coding. You're clean coding hard. You know what I mean? You've got to the point where you probably left the path of good programming at this point. Study time says you're a good human being. How do you defend yourself? This reminds me of the quote in Gladiator where Maximus says to Proximo, you're in danger of becoming a good man. Don't worry, I will disappoint you. I am a piece of shit. It's okay. Don't worry. I have complete understanding of who I am. Not good, okay? This is not something you want to write home about. All right, anyways, I've seen other engines manage to this mess by offloading the template argument specification to a myriad of type defs. I've seen this too. It's crazy. It's even worse, yes, because the definition jumping is insane. It might make local code easier to understand, but it creates another layer of disconnect between local code and overarching system logic, making the code not hint towards system design, which is not beautiful. I love the use of beautiful here. Proxima. Oh, dude, isn't it so good? You can't be prime home. I'm not even sure what that means. For example, let's say there was code. Okay, yeah, and this. I actually agree. I feel like, I guess in some sense I do like type defs. They can be really nice. In Go, I know that you can use a type def and then attach methods to it. So if you have it, even though it's like an int, you can attach nice little methods to it. Like, there is some really good stuff. But I also understand that, like, when you overly type def things out, in this case, it's just really difficult to understand. Right? It is just really difficult to understand. It's possible that the string hash table's memory allocator, string allocator, won't contribute to the global memory, which would cause you confusion. You'd have to backtrace through the code to find out where string hash table is actually a type def of a mess of templates, parse through the template code, and find out that it's a different allocator, and find that allocator, and blah, blah, blah. It's ugly. Agreed. Doom does the complete wrong thing according to common C++ logic. It writes things as non-generic as possible, using generics only when it makes sense. Let's go, John Carmack. I love this. I love this take. This is so good. What does Doom hash table do when it needs to generate a hash of something? It calls ID stir get hash, because the only type of key it accepts is a const char star. What would happen if it needs a different key? My guess is that they template the key and just force it to call key.getHash and have the compiler enforce all the key types have the int getHash method. Awesome. This is so good. Remnants of C. I don't know how much of the id's original programming team is with the company anymore, but John Carmack at least comes from a C background. All id games before Quake 3 were written in C. I find many C++ programmers without a strong C background over C++ized their code. The previous template example was just one case. 3 other examples that I can find are the use of get-set methods, string streams. String streams are crazy. Crazy string streams. Excessive operator overloading. Okay, who doesn't like a good old-fashioned operator overloading? Right? Who doesn't love a good old-fashioned operator overloading? It is very judicial in all these cases. This is a waste of lines of code and reading time. It takes longer to write it and read it comparatively. Class type, public var. What if you're often increasing var by some number n versus get set var? Yeah, I mean, this is just Java bleeding into it, right? This is just Java bleeding into the situation. You know what I mean? Everyone's kind of seen this. Being too dogmatic on any language is bad. I blame this on schools, not on the language. Fair. This is fair. This is definitely the Java side of things, trying to be like, you need getters and setters. They're the best. Don't worry, it'll be inline, blah, 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 blah. And it's just like, yeah, but it's super annoying. You know what I mean? If you have no friends, no operator overloading for you. Just use a struct, dude. No one forbids it. Yeah. Hi, Mom. The first example is much easier to read and write. It doesn't use string streams, and string streams probably contain the most extreme bastardization of operator overloads I've ever seen. The double this direction. I do agree. I've loathed this for so long. I've loathed it. I don't like it. That's ugly. It does have strong advantages. You can define the equivalent of Java toString method per class without touching the class's vtables, but the syntax is offensive, and I'd choose not to use it. Choosing to use printf instead of string streams can make their code easier to read, and thus I think it's correct decision. The only downside of printf is when you get like slightly incorrect type passing into printf, and you can cause some weirdities, right? Printf, I actually don't mind this. Oh, look at that beautiful HTMX horse. Look at that. Look at that beautiful one. I teach all my junior devs on how to write guard clauses. They make the code so much readable. Yeah, I do like a good early return is nice. Let's see. Syntax for some classes operators would be ridiculous too. Look at that, dude. So disgusting. Why would you do that? Side note, John Carmack has stated that static analysis tools revealed that their common bug was incorrect parameter matching in printf. It's like I predicted the future there. I wonder if they changed the string streams in Rage because of this. GCC and Clang both find printf parameter matching errors with wall, so you don't need expressive static analysis tools to find these errors. Another thing that makes Doom code beautiful is the minimal use of operator overloads. Operator overloading is a very nice feature of C++. It allows you to do things like this. Yes, you can do it in Rust too. I'm not sure. I actually think C++ might have it slightly nicer. Rust is a little weird. You implement these traits, and there's like a lot of cases to it, like doing the add one. You know, you really got to do all these different cases because of how, you know, the borrow checker works and who owns who and do you produce a new version or not. It's like there's a lot to that. You know what I mean? There is a lot to that. Without overloading these operations would be more time consuming to write and parse. Doom's steps here. I've seen code that doesn't. I've seen code that will overload operate the percent to mean dot product verse or operate vector star vector to do piecewise vector multiplication. It doesn't make sense to make the star operator for cross product because that only exists in 3D. What if you wanted to do 2D vect times 2D vect? What should it do? What about a 4D or higher? It's minimal operator overloading that leaves no ambiguity to the reader of the code. Fair. One of the biggest things I've learned from Doom code was a simple style change. I used to use classes that looked like this. Oh baby, look at that code. Oh, look at that code. And what they're doing is this. What? According to what? Okay, like, I think John Carmack is one of the greatest programmers of all time, and I have absolute commanding respect for Carmack. But whatever this style of code is, it honestly makes me want to vomit. This is crazy. This is crazy looking. What am I supposed to do with this? I love the fact that the two different constructors here, they don't have, you don't define return types on constructors, so it's just like empty space. Like, there's so much stuff. This is crazy. Man, let John cook? I don't know. I don't think I should let John cook on this one. Oh, gosh. I don't like that. I don't dislike that just because I write Haskell. Dude, your phrase, your statement makes me think you write Haskell. You know how many knots are in that phrase? Crazy. Okay? Crazy. That bro hitting tabs. So many tabs. Dude, crazy. They rarely put the inline functions inside the class definition. The only time I've seen it to where the code is written on the same line as the function declaration. It seems this practice is not the norm and is probably frowned upon. This method of organizing class definitions makes it extremely easy to parse. I don't know. I don't like anything where I have to like be really precise on looking back and forth, right? I don't want to because imagine a wall of definitions. It's hard. It's hard. Since you'd have to retype a bunch of information defining the class. Yeah. Inline, string, yeah. I'm against all extra typing. There's literally extra typing right here. I need to get stuff done as fast as possible, but this is one situation where I think a little extra... Okay. He owned me. He saw me coming and owned me, okay? Owned me on this one. Very, very much so. Let's see. A little extra typing when defining the class more than pays for itself each time the class definition needs to be parsed by a programmer. There are several other stylistic examples provided in Doom 3 coding standards, and that contribute to the beauty of Doom source code. Method names. I think Doom's method names rules are lacking. I personally enforce the rule that all method names should begin with a verb unless they can't. So I actually... Let's see. For example... is much better. So I prefer the other way. At this point, I think I actually prefer just the thing as opposed to the get part. I don't like the whole enforcing of a verb anymore. I used to be that way, but it makes more sense to be able to just be like length than get length. I just don't think you need that. I don't think you're getting anything extra out of this. Yes, it's beautiful. I disagree with this point. I like all the other points, but I disagree with that point. I was really excited to write this article because it gave me an extra excuse to think about what beautiful code is. I still don't think I know, and maybe it's entirely subjective. I'd say the only time I've truly been struck by like beautiful code is no matter how ugly it is, it's when someone solves a problem so different than me, it feels like I've unlocked a new way to solve a problem in my brain. Has anyone ever had that? It's like where you see something done so different than how you would approach it that you're just like, oh, wow, right? Like it's so cool. It's such a great experience. It's magical. And it doesn't happen very often, but when you do see it, it's progasming. Like, that's the first time progasming has ever been found and recorded. And it's true, and it feels good, and I've been chasing the high ever since. I love reading code just in case I find another one of these, right? You never know when you're going to have your next progasm, but when you do, so good. Why not? A lot of stylistic choices are definitely my personal preferences, and I'm sure other programmers will have different opinions. I think the choice of what style to use is up to whoever has to read and write the code, but I certainly think it's something worth thinking about. Absolutely. Here, let's go down to the John Carmack one, because I actually do want to see this John Carmack one. Here, let's go back to the previous one, because I had it out, and I really did want to see this one. All right, John Carmack. A few comments. In some ways, I still think Quake 3 code is cleaner as a final evolution of my C style, rather than my first iteration of my C++ style. But it may be more of a factor of the smaller total line count or the fact that I haven't really looked at it in a decade. I do think good C++ is better than good C from a readability standpoint, all other things being equal. I sort of meandered into C++ with Doom 3. I was originally an experienced C programmer with OOP background from Next Objective-C. Ooh, sorry. So I just started writing C++ without any proper study of usage and idiom. In retrospect, I very much wish I had read effective C++ sitting right there on my counter. Let's go. And some other material. A couple of the other programmers had prior C++ experience, but they mostly followed the stylistic choices I set. I mistrusted templates for many years, and I still use them with restraint, but I eventually decided I liked strong typing more than I disliked weird code in headers. The debate on STL is still going on here at ID and gets a little spirited. Back when Doom 3 started, using STL was almost certainly not a good call, but reasonable arguments can be made for today, even in games. Okay, base take by John. I am a full const Nazi nowadays. That's not a phrase. Bingo card 2023, not a phrase that was going to come out of my mouth, but it just did. And I chide any programmer that doesn't const every variable and parameter that can be. A major evolution that is still going on for me is towards a more functional programming style, which involves unlearning a lot of old habits and breaking away from OOP directions. This is great. Honestly, this is great. I think that it's, you know what? I completely agree with Mr. Carmack on this statement. You really should strive to make everything constant as you can. It just reduces the amount of potential change, but it's not really about mutation that I'm worried about. It's about sending a signal to other people that what you have designed, these points change. You can tell somebody where change occurs. And that's one thing I really do like about Rust is that it's const as basic definition, mute as what you have to opt into. And I truly do think that that is the best or one of the best features of Rust is mute as an extra word you have to add on. Const should have always been the default. He actually had a post in 2014. He actually became more and more of a functional programmer. Yeah, I know. I saw that one. That good. Performance sucks when you forget it. Yeah. I mean, there's all these other reasons why you should use const, but I think for the biggest one is that you get to understand it. You know what I mean? You get to look at it and see it. And I think that right there is more beneficial than anything else. All right, hey. Sometimes you have a non-const parameter in an interface and one in implementation. It can be constant. The check style complains that it's not const. I hate that. Yeah, that's crazy. I don't know how to deal with that one, but that is kind of rough. The name is the beautiful Codagen.